Hello there, Mr. Wilson here again for another episode of How Do I Help My Child With? And in this episode, we're going to look at multiplying decimals. Now, if you see my previous video, I talk a lot about multiplying whole numbers, and I give three different methods to do that: short column, long column, and grid method. Now, we are still going to use those today, that's why they're in our keywords, because the main method that I feel is pretty standard amongst the majority of schools in the country now is this method of compensation. A word that looks really scary, but I promise you it's not as bad as what it might seem. So to multiply decimals, the pretty standard method now is to use something known as compensation. And that relies on the idea that you can multiply whole numbers. So if your child is not confident in multiplying whole numbers, I would highly recommend looking at my previous video before having a go at multiplying decimals, because it is essential that they are pretty confident with multiplying whole numbers before they give this idea of compensation a go. Now, the best way of me telling you how to multiply decimals is to show you a typical homework question, as I always do. So let's have a look at this question then and see what is the method to perform this calculation. How might this calculation differ for higher levels, lower levels? But we'll have a go at this first. So the question is calculate 23 times 4.3 without a calculator. So this could be a very typical non-calculator question. Now, on the face of it, that question looks quite tricky because it's got a decimal. So some students are sort of tempted to do something like this. So they will set up the column like this and try to do the multiplication like that. Now, it is sort of possible to do it like this. However, I would never ever recommend this, purely because there is so much happening here, because with the place values being in different places, that it can get really confusing about where you place the values in the answer. Like, for example, this 3 times 3 is 9. Where does the 9 go? Or 4 times 3 is 12, but where does that 12 go? 2 times 3 is 6. Where does that 6 go? It can get really confusing for a lot of students. It is possible, but I would never recommend this. So what would be the method that I would recommend, and what method is pretty standard amongst most teachers, is this method called compensation. Now, that word doesn't tend to be used quite a lot, but it is a word that is out there to refer to this idea. So let me show you how it works. So, well, first of all, let's imagine for a second that I don't have 23 times 4.3, I have 23 times 43. Now that question is so much easier than the original one because, as shown in the previous video, I know how to multiply whole numbers. So I can just use whatever method I'm comfortable with for multiplying these whole numbers. That's why many teachers now recommend this method, is because a lot of students can get some method from working out stuff that they should be comfortable with. So I'm going to use the grid method for this, but please feel free, if you want to give this question a go yourself, to use the grid method or the column method, whatever method is best for you. So for the grid method, I set out my values as 20 and 3 times 40 and 3. So 40 times 20 is 800, 40 times 3 is 120, 20 times 3 is 60, 3 times 3 is 9, and then I add up all these values together. So I get 800 plus 120 plus 60 plus 9. And if I add from right to left, I get 9, 8, 9. So 989 is the correct answer for this multiplication. So that is a huge step in this method. That's probably about 80% of this question, is working out that answer, which is why we recommend it, because if a student was to attempt this in the exam and they only got that far, they would still get marks for the method, because they've clearly shown that there is some kind of, well, we're going to discuss it in a second, but there is some kind of link between the original question and this one we have just worked out. So what is this link then? Well, originally we had 23 times 4.3, and now we have 23 times 43. Well, the only thing that is different between these two is I've taken this number here, this 4.3, and I've multiplied it by 10 to get 43. But everything else has stayed the same in the question. So that means that this answer is actually 10 times bigger than the real answer, the answer that I actually want, because I've times 4.3 by 10 to get 43. So that answer is now 10 times bigger than the actual real answer. So if I want the real answer, I need to do 989 divided by 10. I need the answer 10 times smaller to get the actual correct answer. And I've already done a video on multiplying and dividing by 10, 100 and 1,000. So to sort of cut to the chase, 989 divided by 10 is 98.9. And that is the correct answer. It is 98.9. So and I really like this method. And the reason why we call it compensation, by the way, is because compensation is the idea that you compensate for something. So the idea is that because we've multiplied by 10 and made this 10 times bigger, the answer is now 10 times bigger. So in order to get the actual answer that we want, we have to divide by 10 to compensate, to balance it back out again, which is why it gets its name, compensation. Now, the reason why I love this method so much is because it's allowing students to make links between different questions that have similarities between them, which is a sort of deeper level of understanding. Understanding the idea that there is a link here between these two questions, so there must be a link between the two answers, is a deeper level thought than just trying to work this out separately to trying to work this out. So that's why I love this method so much. Now, there are many, many ways that they could make this sort of more difficult. So, for example, if they had something like this, well, this I would work out 14 times 248, work that out. But because they've divided, this has been times by 100, I have to therefore divide my answer by 100 when I want the actual answer again. They might even change both numbers. So, for example, if I wanted to work out 2.3 times 4.3, well, I know 23 times 43 is 989. So because I've timesed this number by 10 to get 23 and this number by 10 to get 43, I've got to divide by 10 twice because I've times both by 10. So I need to do 989 divided by 10 divided by 10, and that gives me 9.89. And that is the correct answer for that calculation. So just be wary, they could change both of them into decimals, but actually, again, if you know what the whole number calculation is, you should be able to sort of make a link between these two questions. Now, there is a wonderful check for this, right? Because the biggest mistake that students make is they get the decimal point in the wrong place. So, for example, if I was trying to do, I don't know, something like 2.3 times 0.43, and I know this answer, some students might say, oh, it's 9.89. Right, so they've done this calculation, they've got 989, and they say this is 9.89. I know for a fact that that can't be right. Without even working this calculation out myself, I know it's not correct. And the way that I know it's not correct is through an estimation. A really wonderful way of checking multiplying by decimals. So let me just rub out some of these so it's not too messy, and then I'll show you what I mean in a second. So let's turn back to our original question, which was 23 times 4.3. How do I feel pretty confident that the answer is 98.9? Well, 23 is around about 20, and 4.3 is around about 4. 20 times 4 is 80. So the answer should be somewhere close to 80. So for example, if I said that the answer was 9.89 because I'd accidentally put the decimal point in the wrong place, that is clearly not the answer, because the estimation, the rough answer, because I've just sort of approximated these numbers. 23 is about 20, 4.3 is about 4, so that gives me 80. 9.89 can't be the answer because it's so far away from my estimation that clearly I must have put the decimal point in the wrong place. The correct answer is 98.9, which is significantly closer to to my estimation. And you could even get a more accurate estimation by using some, instead of 20, you could just use 23 times 4, which gives 92, which is far closer to the correct answer of 98.9. So an estimation will very quickly check whether the decimal point is in the wrong place. It's not going to be super accurate because that's the whole point of an estimation. It's supposed to be quick and easy to perform, but it will make sure that that decimal point is in the wrong place, because there is a big difference between 9.89, 98.9 and 989, and clearly the decimal point matters here. So you know it's got to be one of these answers. You know it's got to have 9, 8 and 9 in it, but where does that decimal point go? Once you've decided where it's gone, a quick check with an estimation is a fantastic way of making sure that you've got the right answer. And I would recommend any student to check their answer, whether they are the best mathematician in the world or not very confident with this, because it literally takes 15 seconds to check that answer. So if I was a parent and I was seeing my child have a go at a question like this, I would be making sure that they are checking their answer. And they'll probably roll their eyes at you and say, oh, I don't need to check it, I've got it right, or whatever. But I think it's vitally important that we make sure that students are in good habits for when they get into the exam. They can't just be sat there watching the clock run down. They've got to be checking those answers. It's so easy to put the decimal point in the wrong place and get the answer wrong. So please encourage your child to make sure that they check their answer. Okay, so I think that's about it for this video. Thank you for if you've watched to the end. Thank you for watching to the end. You must be a dedicated viewer. Hopefully this has been helpful for you. Again, this method was something that I never used when I was learning how to multiply decimals all those years ago. It's a method that I teach now, but I'm just so amazed at how maths has evolved, and I look at this method now and I think, why didn't I do it like that when I was taught? Because it's such a clever way of multiplying decimals. It makes it so much easier than the way I used to have to do it. But anyway, if you've got any questions or any sort of concerns, or if your child is doing something a certain way or whatever, please do not be afraid to drop something in the comments. I always try and read the comments daily, in fact, and I'll try and respond to them when I can. But please don't be afraid to use that comment section as a sort of almost like a Q&A about any concerns that you might have or any questions, or if there's anything in particular. It might not be about this topic, but anything in general to do with maths, then please let me know, because there is absolutely no shame in asking questions, right? I want to break this stigma that maths is horrible and it's nasty, and that people don't understand it. Maths is understandable. People do maths every day, and we need to make sure that we encourage people and that make people feel welcome, and sort of ease people into the idea of maths, because once that happens, people realise that it's probably not as bad as what they remember it at school in most cases. Anyway, all I want to say is thank you so much for watching, and hope you have a fantastic day.